In this problem, it is a redox stoichiometry problem. So the first thing we have to do is looking at question number 1, we need to balance the equation, and we see that it's an acidic solution. So first step is to identify our sign oxidation numbers. I know that oxygen is a -2. A -2 times 3 is a -6. Bromate equals a -1, which makes Br have to be a +5. What's nice is everything else already has its oxidation states listed. So then I'm just going to take a look and see who changed. So I noticed that Br went from a +5 to a -1. So I'm going to write that down. I'm just going to write down the BrO3. Br is a +5. And now it's going to be our -1. And so from +5 to a -1, I have to take a +5 down to 0 and 1 more. So I notice that I'm going to gain 6 electrons because if I have +5 minus 6, it's going to equal a -1. So this is reduced. So this is reduction because I've gained electrons. And so since it's reduction, the BrO3 is going to be the oxidizing agent. So the agent is providing or taking the electrons for the thing that's going to be oxidized. The agents have to be a reactant. It cannot be a product because agents are a cause. So I know that BrO3 is going to be my oxidizing agent. So then I look and see that SB, so SB went from a +3 to a +5. So again, I write the electrons always on the side that's most positive because I want to get it to even out, and so I know that a +5 minus 2 is going to give me that +3. So then my E's have to match. I have 2 electrons that are lost, but 6 electrons that are gained. Well, it can't happen. They have to match. So I'm going to multiply the SB reaction by 3. So when I do that, if I distribute that out, I'm going to have 3SB plus 3, 3SB plus 5, and 6 electrons. So now my electrons can cancel out. So what I'm going to do for this particular reaction, just to save room, is I'm going to put this stuff back up in, just so that I can get it balanced out. So one step before I do that is we can notice that the SB is oxidized because it lost electrons. Okay, remember oil, oxidation is loss. So the SB plus 3 is oxidized, so therefore that makes it the reducing agent. So I know this is the reducing agent. BrO3 -1 is the oxidizing agent. So when I put these back in here then, so I have 3 for the SB plus 3, and then 3 for the SB plus 5. My last step is to balance out my oxygens and my hydrogens. Because it is in acidic solution, it told me up in the problem that it's occurring in some hydrochloric acid. I know that for every oxygen that I need, I add a water. So over here, I have BrO3, so I have 3 oxygens. So I don't have any oxygens on the product side, so I'm going to add 3 waters. Every time you need an O, you add a water when it's in a acidic solution. So now I take a look at my H's. So on the product side, I have 3 times 2. I have 6 H's. I don't have any H's on the reactant side, so I'm going to add 6 H pluses. Do not forget to make that a hydrogen ion. So I have my balanced equation, and so the last thing I need to do now is, or actually work through the problem. So it wants to determine the number of grams of this SB, the antimony, in the sample. So if I go up to the problem, it lets me see that my sample is 9.62 grams. And that sample gave me some information that it reacted with 43.7 milliliters of 0.1250 molar KBrO3. Well, I know that for every 1 mole of KBrO3, I have 1 mole of BrO3 minus. And so that helps me when I look down at my reaction. So the first thing I'm going to do is go ahead and convert this. So I know that molarity times liters is equal to moles. So I have the molarity. I put a little times there. I always think of the as a time symbol because molarity times liter is moles. And so I know that my liters, I need to convert this, move it over 3. So I'm going to have 0.437 liters and I have to convert this because I'm going to be dealing with grams. I know my molarity is 0.1250. So when I multiply that out, I end up with the small number, 0.00546 moles of BrO3 negative 1. Well, then if I look down, I see that the mole ratio for BrO3 and SB, if you take a look, there's no number in front of BrO3. In front of the SB, there's a 3. So I know that the ratio, the mole ratio, is that for every 3 moles of SB plus 3, I'm going to consume 1 mole of BrO3. So I know that the ratio is 3 to 1. So I can work that out really quickly just by multiplying by 3, and I get 0.01638 moles of SB plus 3. So then simply I just take that and I take my moles of SB plus 3 Okay, so the next step after we know our moles of SB plus 3, that we just find the grams. And so we go and we look up. So if we take down here, I'm just going to go ahead and add it down here. So we know our moles of SB from what we calculated, 0.0163 moles of SB plus 3. And so then I'm just going to convert that by using the molar mass. SB, antimony's molar mass is 121.75 grams per mole. So then I just multiply that out. Since I don't quite have a mole, quite a bit smaller than a mole, that comes out to be 1.99 grams of antimony. So to figure out the percent then, you just take the amount of antimony that's in the sample, the 1.99 grams, almost 2 grams of antimony, and divide that by the total of this mineral, so the 9.62 grams, and times that by 100. And so we can easily see that the percentage is a little over 20%, so 20.7%.